This is the first image we're starting with, captured recently by Tony Scarato in Italy. As 3i Atlas continues its approach toward perigee, at first glance it looks simple. A bright central source, a broad surrounding glow, and a tail stretching out at a clear defined angle. But look closer. The coma is large and well-formed. The brightness is concentrated, not smeared. And the tail extends for several arc minutes, holding its direction instead of fanning out. This is not a fading object. This is an object that's still structured. And that matters because at this distance in geometry, we'd normally expect things to soften, not sharpen. Now, keep this image in mind because when we enhance it and compare it with what comes next, the story starts to change. Now stay with this observer because this isn't a different telescope or a different night. This is the same data set pushed further. When Tony Scarato applies enhancement processing, a much larger structure snaps into view. A long anti-solar feature extending at least 250,000 kilometers away from the central region. That's not a subtle edge effect. That's not background noise. And it doesn't vanish when the processing changes. The orientation stays consistent, the structure stays attached, and its scale becomes impossible to ignore. This is where the image stops being just a point of light and starts behaving like a system with direction and structure. Now we move away from ground-based telescopes entirely. This image comes from NEOSSat, an orbiting space telescope. Different optics, different vantage point, no atmosphere in the way. And yet the same core behavior shows up again. The central region stays compact. The surrounding glow remains asymmetric. And the orientation matches what ground observers were already seeing. That matters because when space-based data lines up with backyard and professional ground observations, it rules out local seeing conditions, tracking errors, and processing artifacts. This isn't one telescope catching something odd. It's multiple systems in different environments, all pointing to the same structure. Whatever is shaping 3i Atlas right now, it's persistent and it doesn't depend on how or where we look at it. Now look closely at this next frame. This isn't a color image. It's a contour plot pulled from node data designed to strip everything down to structure alone. And what it reveals is important. The brightness isn't symmetric. The intensity contours stretch sunward, forming a defined directional feature instead of a smooth, rounded envelope. That shouldn't happen if material were dispersing evenly. Instead, we're seeing a coherent structure anchored to the central region, holding its shape across multiple contour levels. This isn't a single bright pixel. It's a layered signal repeated across independent brightness thresholds. In other words, this structure survives aggressive processing, which means it's not noise and it's not an artifact. When you combine this with the ground-based images we just saw, the picture sharpens. Different telescopes, different techniques, different observers, same geometry. When you put these together, the picture sharpens. What Tony captured from the ground and what NEOSSat recorded from orbit are not separate stories. They're the same structures seen from different distances, with different instruments processed in completely different ways. The direction lines up, the geometry holds, and the scale doesn't collapse under scrutiny. On the ground, we see the extended structure stretching deep into the antipolar direction. From space, contour analysis pulls out the same feature, still a line, still coherent, still anchored to a compact central region. That matters because when aggressive filtering, contour mapping, and raw optical imaging all agree, we're no longer talking about processing artifacts. We're looking at a real persistent structure, something that survives changes in viewpoint, survives changes in technique, and stays locked in the same orientation over time. That doesn't tell us what it is yet, but it does tell us this: whatever is shaping 3i Atlas right now is active, is directional, and is still evolving. So the question isn't whether something changed. It's what mechanism can produce this kind of stability at this scale, this close to perigee. And that's what we need to talk about next. 3i Atlas makes its closest approach to Earth on December 19th. By then, we'll know whether this structure holds, fades, or transforms again. So, here's the real question. Are we watching a temporary phase driven by changing solar conditions? Or are we seeing a deeper, persistent process revealing itself as this object passes through the inner system? What do you think today's new images are telling us? Drop your take in the comments. I read them all. And if you want to follow 3i Atlas as it evolves day by day, make sure you're subscribed. Share this with someone who's been tracking this object too, and stay curious.